Okay, so today we're going to work on chapter 6. And I wanted to do something from the test. Um, on one of the questions had to do with getting a unit price. And I don't have an example in front of me, but what happened is people divided it out. Let's just say it was $1.80 for 6 ounces. Okay, and they wanted the unit price. And so what you did was you took $1.80 and you divided by 6. And so I use these numbers because then I can do it in hand. 6 into 18 is this. So if you were saying the answer to this, the unit price is 30 cents per ounce, you would say it like that, 30 cents per ounce. But this answer here with the decimal point is in dollars. So what you had to do is put it in cents. And that's the way the question read. So when you change dollars, which this is in dollars, to cents, the decimal comes over 2 to the right. So you would say 30. Now, 5 or 6 people, I'm pretty sure, said 0.30. They just copied the number, but that would mean it was only a fractional part of 1 cent. And that's not the case. It's actually 30 cents. And so dollars to cents is 2 decimal places. And so then you would say 30. Any question about that?
Thank you for explaining that because I had a double of a time trying to figure out what I did wrong. So thank you.
Oh, okay. Well, what happened, I gave people, if they had this, I gave them half credit because they had figured what to do. They just hadn't, hadn't gotten it in the correct form. So, yeah. So I did fix those that I could. And so I looked at everybody's. So this, what we're going to do today is chapter 6. And so chapter 6 is about percents. And the first thing they're going to do is talk about percents and decimals and fractions. So we've already done decimals and we've already done fractions. Like it or not, we have. And so they're connected to percents. And so the first thing I want to do is talk about the language of this. This is 5%. Now I'm going to write it in words, 5%. So if the sales tax was 5%, which it's not, but let's say it was, the word per, when it's between 2 numbers, means divide. So the literal translation of 5% would be 5 per is divided by cent is 100. So when they say 5%, you basically can write it like this. Now, typically, if you're going to do a computation with 5%, one way to write it would be the fraction way, 5 divided by 100. The other way would be the decimal, and 5 divided by 100. I don't know if you remember when we were multiplying by 10 and you multiply by 100 and so on. It's a decimal shift. Now, when you divide by 100, it's a decimal shift, but the shift, there's where the decimal point is. When you divide by 100, It's a 2 decimal shift and it goes in the opposite direction. So the answer is 0.05. So if you're going to do the computation of 5% of a number, it's 0.05. Now, of course, the front zero that we're used to. But notice that's all that happened was a decimal shifted 2 to the left. So which is easier to do? In most cases, the decimal way is the easier way to do it because you pull out, you know, for most people, you pull out your calculator and you just plain do it. But once in a while, the fraction way is actually easier. And I'll show you when that comes up. A few of the problems, it's actually easier to use fractions. But if you're going to do a computation, you don't multiply by 5. If you want 5%, it's either 5 divided by 100 or 0.05, the decimal way. So
And is 100 gonna be like equal to cent every time?
yes, the cent translates into 100 every
Okay,
time. So
gotcha.
and division is a 2 decimal shift. But remember, when you divide by something, you're going lower. And so that's why you go left instead of right to make it bigger. You know what I mean?
Can you do that in money, please?
Gotcha.
It would be like, would a cent be like $100 and 5% off? Can you do it in money, please? So I can understand a little bit better.
So if something cost $100, okay, and the tax was 5%. So we're not going to multiply 5 by 100 because that would be $500 tax. That'd be terrible. Can you appreciate it? So 5%, I'm going to go the decimal way for now, okay? 0.05. So it's really 100 times 0.05. Let's do the decimal way. So 5 times 0 is 0 and another 0, and 5 times 1 is 5. When you move this over, 1, 2, 1, 2, the tax would be $5.
So you do the fraction as normal. I mean, you
Yeah,
do it as normal. Just the end of it, you just move the decimal places.
right. And this is the decimal approach. Now, the fraction approach would have been just as easy. 5 over 100 is 5%, literally 5%. And if you multiply it by $100, the hundreds would have canceled, and you're left with 5 over 1, which is $5. That's your tax. So in this particular case, fractions, you know, fractions sometimes are more problem than they're worth. But in this case, it didn't matter which way you did it, multiplying by 0.05 or recognizing it 5% is really 5 over 100. So I want you to start to see that. So
Is it gonna be out of 100 every time, or is it gonna be out of like 75? Can it be like out of like 60?
well, it depends. Every problem's going to be different. So I just started with $100 because that was easy to do.
Mhm.
But most problems won't be that. And
Okay.
that's why you might like the decimal better. Let's take 6%. Write it as a fraction.
1 over 6. 6 over 1 over 6.
Nope.
6 over 1.
6 over 100.
Cent
Ah,
per cent.
sorry.
Okay? Now, the instruction, this first set of instructions was with the denominator 100, so this is what they wanted. But typically, when they're asking for a fraction, then they would expect you to reduce it. Okay? But this particular problem, they said, just write it with the denominator 100. So that made it easy. Can you have more than 100%?
If it's out of like a bigger number, right?
You can. I mean, sometimes the price of things goes up more than 100%. 100% would mean, you know, you're adding the same amount to it, but this is even more. So what would this be as a fraction?
160 over
160 over 100.
Correct. And so if the instructions continue to say, write it with over 100 with a fraction denominator 100, that would be your answer. Okay. So let's see what else. Now let's 35.2%. Now I want to turn this into a decimal. Okay. So it's clearly, I'm going to organize this for you in a minute, but clearly, let's do an easier one. 25% into a decimal. Anybody know?
0.25.
Correct. Percent, literally, is dividing by 100. And so dividing by 100 is a decimal shift. This is what percents are good in this way. Dividing by 100 takes you back 2 places to the left. So it's 0.25. You could put your front zero in like a good person, but that's it. So we're taking percents to decimals. Now this one, the simplest thing to make it a decimal is to shift it's already a decimal. Let's shift the decimal. What would be your result?
352.
You go the other way.
Oh,
Notice how we went this way, right?
mhm,
Which way?
this
What?
way. 2,
This way. So it's 0.5.
0.35.
That's right. Okay. Now, typically, if you had a decimal and somebody said, oh, I want the percent, it's the reverse. So decimal point 27 hundredths, if you say it, you know what it is. What percentage is that?
27%.
27.
So the very first thing, let me do this one. I wanted a percent.
Would it be 5%?
Well, let's compare this one. 1, 2.
Oh,
50 cents, 50 cents.
It is 50%. This was 0.5, which is 0.5 is 5/10, which is 1/2, 50%. Okay.
it's the reason it's 50% because it still has to move 2 spaces because of the, oh, okay, thank
That's
you.
right. That's right. So when we had decimals and percents. I'm gonna make a chart here so that we can keep this straight. Yeah, when we had, let's say, 14%. The decimal is 0.14. So notice what happened. We moved it this direction 2 places. 2 places to the left. So 89% would be what?
0.89.
72.4%.
Point
Zero,
724.
It's always 2 places, so 7, and don't throw away the 4, just bring it in. So we meant 2 places, I put the, like that. Okay? Now, the reverse is this. If I had a decimal, 0.76, and I wanted to make a percent,
76%.
yes. And I want you to see what we did with the decimal. It was here and it moved over here. So in this case, we took it decimal 2 places to the right.
I'm sorry. What's the difference between sometimes we move to the left and I know it's obvious, but I'm not getting it.
It depends.
Why sometimes it's left
Yeah.
another one?
Okay, it depends on what you have and where you're going. So what happened was, in this particular case, the first 3 problems I did, I started with the percent.
Okay,
So if I had the percent and had to go to the decimal, notice the direction I'm going,
the left.
to the left. You see? That's why I made my chart like this. 2 to the left.
Left.
On the other hand, when I changed it up and I gave you the decimal first,
Oh, 2%. Then it's 2 to the right.
decimal, this is the instruction. Then you took it and you went back here.
Amazing. Okay, thank you.
Now,
Broke down the
if you memorize just one example that's pretty easy, like 0.25, and that's 25%, this basically tells you the direction. In other words, when it was the decimal and it needed to be the percent, you had to go to the right. 2 places, because this is percent. When you had the percent and you wanted to get back to the decimal, you had to go to the left. 2 places.
I've been mixing that up my whole life.
Memorize one
Okay.
simple problem. You have got the formula.
Okay, thank you. That's
Right?
Yes, thank you so much.
All right. So now let's see what we need to finish this off is to complete the table. And the order actually matters. And I have seen this in a book. Fraction first, decimal second, and percent here. So what we were doing is going back and forth between these 2. So it really doesn't matter. Let's see, let's do 0.09. And if you want the percent,
9%.
9%. Remember, when we went this way, it was 2 to the right. So if I started here and had to go to the percent, I had to go in this direction. The chart is giving you the direction. It's supposed to help. If I had 4.9% for starters and had to go to the decimal,
0.49.
so you've got to go 1, 2, like that. So it's 0.049 with the front 0. And so this direction was basically the instructions were 2 places to the left. Okay. Now, let's say I wanted to fill in the whole chart with the fraction. Sometime I could fill it in. Was 9% as a percent, 0.09 as a decimal. What is it as a fraction?
9 over 100.
It was 9 over 100. And in general, you know the game. With fractions, they're hoping you're going to provide the simplified, reduced answer. And 9 over 100 doesn't reduce anymore, does it?
Nope.
No. Now, anybody want to attempt the fraction on this one?
I say 0.49 over 100.
Almost, but this, if you look at the decimal, so there's two possible ways to do this. One is to go with the percentage and then bring it over, which would have to be 4.9 over 100. But I hope that's looking like that's not really the way they like it, with a decimal inside of a fraction, right?
Mm-hmm.
Okay,
So they would, what we did last time is you would multiply this by 10, 1 decimal place, and this by 10.
So 40,
And so what would that be?
49 over 1,000.
yeah,
Or
490.
0.49
Oh, 400.
over
90 over.
1,000.
I'm sorry, 49 over 1,000.
Okay, 40. Okay.
Now, 49 over 1,000. Now, that would come off of this. This one would have been a direct one. This is tenths, hundredths, thousandths, right? Tenths, hundredths, thousandths. So that would have been 49 over 1,000. So this one would have given it to us immediately. Okay, but regardless, we would have gotten the right answer regardless. Let me see. Let's try this one. Okay, this is different. I want a percent. Now, all you have to do, and it's a little bit weird, is follow the rules. So which way does the decimal have to go?
That one, the right one.
To the, so what's your number?
Four,
Two,
489?
Yeah,
400, Anna.
I mean, this is
Mhm.
like a really bad, product, but some things have doubled and tripled in price. Have you noticed? You've noticed?
Yep.
There's definitely things that have gone over 100%. So I'm going to continue to come back to this chart, fractions, decimals, percents. This is definitely something we can do. So let me start again with a new fraction, decimal, percent. So I'm going to start with this fraction. So our job is to be able to go back and forth as need be to do the computations. So if this is the fraction, 7/10, can you write the decimal immediately from it? 7/10.
0.7.
Like it?
0.7.
0.7.
This is 7/10.
Yeah,
Okay, so this had nothing to do with percent yet, did it? This was just something we've already done. 7/10 is 0.7. But let's say we then wanted to fill in the chart completely and take this into a percent. What happens?
0.07.
is it 70%?
We're going this way, right?
Mhm.
Which means we're going the same direction the chart is trying to help you.
7%.
70%.
Oh, okay.
Oh. Now now we've got to relate to something so that you can make sense of this. If you had a quiz, this is a little math quiz, and you got 7 right out of 10.
Gosh.
Yeah.
7 out of 10. You're not going to be satisfied with 7%.
Yeah,
You know what
okay.
I'm saying? This is 70%. Does that feel right?
Yeah,
Okay, that's what I wanted. Now, I'm going to do this one because I'm seeing it in where I'm looking. If it's a fraction that you may not know the decimal that goes with it. In fact, I mean, I know it, but that doesn't mean anything. How do we make, so this, before we even get to percents, how do we make a fraction into a decimal? This is something we've already done. I'm going to do it. 3/8. I want to make it a decimal.
Mhm.
Okay,
you did,
remember?
yeah, divide.
3 divided by 8.
That's right. And so I'm going to recopy it because some people don't like the mess. I'm going to add a couple zeros, but it's actually going to take 3. I'm going to bring it up. So 8, of course, doesn't go into 3, but it does go into 30. This is 8 times 3 is 24. When we subtract, we get 6, which
Yes.
is good. It's smaller than 8. We bring this down. 8 into 60 happens to be 7. 7 times 8 happens to be 56, and there's a
56.
remainder of 4. And
Oh,
one more would make this perfect. And
5.
8 is 5. And so this 0.375 is an exact answer. It's not one of those answers that goes out forever and ever. This is exact because the remainder is 0. So in this particular problem, 3/8, 0.375. So the skill to get from here to here is something we already did. Now, can you turn it into a percent? The decimal.
Mhm.
37.5.
What is it now? 3?
7.5.
7.5.
That is correct. The point of this craziness is that sometimes going from a fraction to a percent is easier if you get the decimal first, because the decimal and the percent shift back and forth 2 places this way, 2 places the other way.
Oh,
And
okay.
so
Got
there was a joke in Maine. Somebody would get lost on this, on the highway somewhere, and they'd say, "How do you get from here to there?" And the joke was, "You can't do it. You can't get from here to there."
Mhm.
Well, and they liked, making people get lost. It was just a mean streak. So this one, to get to here, it was easier to go first to here and then to there. That's my point. You see it?
Mhm.
Okay. Let me see what else I can find.
If we divide 375 over 100, can we get this answer or?
Well, 8 doesn't go, if you did that, you would have such a mess. What were you gonna do, 3/8 over 100?
375 over 100. Can we divide that one?
375, you mean like here? 375. If you work from here, this is tenths, hundredths, thousandths, you'd have to do it like that.
Okay.
So I think the decimal shift between these two is the easiest. If it's a decimal, shift it 2 places, depending on which direction you're headed.
Okay, thank you.
Let's see. Okay. So I did mention that there were 2 times when it was easier to work with a fraction than a decimal. I'm going to show you the 2. The fraction 1/3. If you took 1/3 and started dividing it out, here's 1/3. And so you would start dividing it out just like we did the last one. So it's 3 into 10. I'm going to add some zeros. I don't know, I'm going to need a couple. So 3 into 10 is 3. 3 times 3 is 9. 10 take away 9 is 1. Bring down the 0. 3 into 10 is 3. 3 times 3 is 9. Now what?
Bring the 0 down.
So bring another one down. And guess what's going to, can you see the way this is going?
Mhm.
Continue 3.
It's going to keep going, isn't it?
Mhm.
So typically, if you were forced to write this as a decimal, it's like the 3 keeps repeating, which is not a good number to do computations with, is it?
Nope.
And so if you had to make it a percent, remember it was a bunch of 3s,
Mhm.
it ends up being 33 1/3% if you stopped at 2 places and you had a remainder of 1 and you put it over the divisor, it's 33 1/3%. And so instead of using this to do your computation, multiplying by 1/3 is probably the easiest. This is a messy one. And the other one that's a messy one is this one, 2/3. When you divide it, what you do is get 6, 6, 6, 6 forever.
Right.
And so if you had to say what the percent is, it's 66 2/3. So it's interesting, it's not that hard to remember these two. But these are messy ones to use. The fraction is actually the smallest and simplest. And so I just wanted to bring those up. These are the odd ones, 1/3 and 2/3. And a lot of times in a store, they'll say, well, it's 1/3 off, right? Which is a difficult computation, you know, because how do you do that? How do you do that? And so on. But I just wanted to mention these 2 because they're kind of odd. So from that, if I saw, if this was one of your problems, 33 1/3, and we want it written as a fraction. 33 1/3% is what fraction?
1/3.
1/3, don't think about it, just write it. And 66 2/3% is what fraction?
2/3.
That's the end of that. We could do computations for the next 15 minutes, but I think it's easier just to remember that one. Okay. All right. So you'll get a little bit better at fractions and percents and decimals as we go on. But what we want to do next is actually try a percent problem. So here's our first one. What is 15% of 60? The problem with this is it's been taught all kinds of ways. And one way they taught it was there's 3 types of percent problems, and one of them you divide and one of them you multiply, and you have to make sure you do the right division, and nobody got it. Bottom line, people did not understand how to do it. So this particular approach, at least there's 2 good approaches. This is totally doable. And what we're going to do is this is a sentence. This is words. I'm going to turn it into math. And so the number what, they're calling it n, the missing number. N, the word is, I'm translating from one language to another. This is English, this is math. 15%. We could write 15%, but in a few minutes, I'm going to change it to either a fraction or a decimal, whichever seems easier. The word of between 2 numbers is multiply. And 60 is 60. Did you see it? Is goes for equals. The missing number, I'm calling it n. You could have called it x. 15%, the word of between 2 numbers is multiply. So I'm going to take this 15% and I'm going to make it a decimal. Remember,
Take
how
it
to
to
do decimals?
the left.
To the left. Exactly correct. So that would be 0.15 times 60. So I took the percent off, I moved it back to here. It's 0.15 times 60. This is not, I made the numbers so that I didn't have to use a calculator. This is 0, this is 30, this is 0, this is 6. 2 decimal places, 1, 2, 1, 2. N equals 9. How's that?
Right?
It's straightforward. You might not like it, but it's straightforward, and that's the good news. Here's another one. What percent of 40 is 20? You don't have to think,
Yes.
have to translate. What percent n of times 40 is equals 20.
50%.
Correct. Remember how we did these problems where you had a letter and it was multiplied to some number? And you ended up dividing both sides by the same number?
Mm.
Remember, we already have that skill. N equals 20 over 40. I would take out the zeros. 2 over 4 is 1/2. That's not a percent, but that's the fraction. And 1/2 is 0.5, which is 50%, just like you said. How's that?
It's like it's moving in a circle.
Yeah. I'm gonna do one more.
Please do for us one more.
25 is 40% of what number? Okay? You had to guess what you have to do. It may not be obvious that we're going to end up dividing. But what we're going to do is get rid of this darn English and turn it into really nice math. Are you with me?
25.
So I put 25 even.
Down with the English and in with the math. Is that okay?
Yeah, let's turn it into math.
25
for-
is
Equal.
Cool.
40%. Now you could write 40%, or we can, well, let's just do 40%. Of is what?
Supply.
In.
Uh-huh.
It's,
25.
this doesn't exist anymore. Now we're down to this. So it's 25. Now 40%, this is where you have to, this is where that little table, if I can find that table, where is the table? This is where the table, where, so you've got to go back and forth. So we have a percent and we want it to be a decimal. So I have 40% and I want it to be a decimal. Can you tell me what that decimal would be?
0.4.
Yeah, I'm gonna put 40 just so that it looks like you can see the two decimal places, but that was correct what you said. Multiplied by n. Mhm. What do I divide both sides by?
By 0.4.
You said the side with the variable
Yes,
is always the side that we do the division by.
correct. Because we're sneaking ourselves into algebra. And you have no interest in what 0.40 times n is. No interest at all. What you want is what does n equal? The missing number. You want to know this missing number. Okay? And so in order to get, so you have to locate the letter and you want to get rid of the 0.40. You want to get it, and so it's multiplied. So you do the opposite, which is divide. So you always locate the letter and that's where the action is. That's where you're going to divide. So it's,
Cross that out, can't you? Since it's 0.40 over 0.40, I think, okay, I thought so.
and so this, that's 1n, which is just plain n. And if you can do this computation, you've got your answer. So it's 25 divided by 0.40. Like that. So I'm going to move this over 2 places. And I would then have to move this over 2 places. So this would be 40 into 2,500. So I was dividing by a decimal number. So I have to clear the decimal for division. And I moved it over 2 places, so I have to be fair and move this over 2 places. So 40 doesn't go into 25, but it definitely goes into 250 6 times.
Yeah.
This is 10. 40 into 100 goes twice. That's 80. I think one more and we'll have it.
points.
And then 40 into that is 0.5. So it ended up being 62.5. Now, at a certain point in time, some of these problems will let you use the calculator that's on the side. Do you remember some of the, do any of the problems have calculators or not?
No,
There's no, oh, okay. I'm thinking of the other class then. Okay. These three problems I just showed you are the three types. And like one of them we had to multiply, the other two we had to divide, and then you had to figure out, well, divide what by what? Let's see if I can find one. Let me just go to something. What percent of 36 is 18? Do you see how people could get lost in these problems? Because it
I
looks
need
like,
that.
it looks like a word problem, doesn't it?
Mhm.
But it's not. And so this is n of is times. This is 36 is equals 18. This is similar to one we did earlier.
Mhm.
You find the letter and it's on this side. The letter is multiplied by 36. So we have to get rid of 36 the best way we can. The only way we really know is to divide by 36 over here. On the other side, do the identical thing. And we're doing the identical thing because it was equal to begin with. So if we keep doing the same thing, it'll still be equal. You can't just change things and hope for the best. So the 36 would cancel and you're left with 18 over 36, which as far as I can tell is 1/2, but I need the percent,
50.
50. It's again, just another one of those, 50%. And so that's that. Now, there is another method that's shown, and it has to do with proportions. And so it also works equally well. And so I'm going to show you both methods, and then you just use the one that works for you. So let me go back. Let me just find a problem that I like. What is 15% of 60? Okay. Every problem can be turned into a proportion. So if you were any good at proportions, this would work for you. So on one side, I'm typically putting my percent over here, but the book is showing it here, so they may explain it that way. 15 over 100. That wasn't hard, right? The only problem here is where does the 60 go? And with this method, after the word of is the total. And the total always goes on the bottom. So in these type problems, the word of will appear somewhere. And immediately after that word is the total. And so this is where you've got your N. So this is your basic formula. Percent over 100 equals the part and over the total. Now, once you have it correctly set up, you then solve it as a proportion. So in this particular example, 15 times 60. I did that earlier. That's 900. Fifteen times 60 equals 900. That equals 100 times N.
Nine.
Divide. I've had two people quit the meeting. Can you hear it? You can't
Yes.
hear it. That's not a good plan. You've got to hang in here.
Yeah,
Quitting just finishes you off. So the answer is N is 9. Now, this particular method with the proportion works beautifully. Regardless of the type of problem, whether the total is missing or the percent is missing or the part, that first number is missing. It works, but you've got to do the cross multiply thing to get an answer. What do you think about that? Anybody have an opinion about that method?
I like the other one better.
You like the first one better?
Mhm.
I think it'll take you further. Let me see. Let me do this one. 16 is 20% of what number? Let me make it so we can see it.
16 equals 20%.
And the minute 20%
Times
times N or X, whichever letter you like. I think I'm going to make this a decimal. 12.20. What do I need to do?
Gonna multiply the 16 times 0.2, right?
Well,
I mean, divide.
it is.
Oh,
divide.
wait.
You're right, it is divide, because the
Divided by 0.2. Yeah,
whole idea is to get N alone.
yeah.
And the connection is multiplication, so the opposite is division.
Okay.
Cancel, cancel.
That's
So N equals this. Now, 16 over 0.20. You may realize that the 0 didn't have to stay there, did it?
Mhm.
If somebody's comfortable with that, that just makes the problem a little bit easier. So it would be 0.2 into 16. Because trailing zeros at the end don't change anything, so it keeps the numbers smaller. This would still have to be shifted one place to make it a whole number. There's your decimal point, you'd have to shift it one. So the actual problem becomes 2 into 160.
Mhm.
2 into 160.
80.
80.
16. So wait a minute.
So-
16 is 20% of the number 80.
Yes,
Oh,
So 16 is 20% of, this was our answer, 80, right? 80.
Okay.
Now, let's pretend you cared. Remember how I play this game every now and then? Let's pretend you care. It's your money. Do you care? It's your money? Yeah. So 20% of 80, so 80, 20% would be 0.20. 0, 0, 16.
Okay.
Do you ever have a sense it's, somebody gives you an answer and it doesn't seem right? It's like, wait a minute. If they gave you an answer of your tax is now $90, you say, wait a minute. Where's my pencil and paper here? Or where's my calculator or something? 20%, 0.20 times 80 is 16. This is, I checked it out. I made sure that my answer 80 was good. We're pretending we care.
Even though we don't.
I told you the story of a person, I taught them percents. They had been working with a lumber yard because they were doing a lot of remodeling. They were getting a discount and the person that at the store was doing it wrong. She then went to the store and said, talked to them about it and realized they had been doing the math wrong all along. And of course, it wasn't helping her, it was helping the store. They fixed it. Right?
Mhm.
Had no choice but to fix it. And the last part of the story is, and please don't tell anybody else. And that's a true story. Okay. So. So where does this go? First of all, we get to the point where we know how to go from fractions to decimals, percents, back and forth. That's the first section. The second section is to do simple percent problems. But the third section is about applying it. So here's the first question. There was a test with 120 questions. Okay? And the person had 96 correct. What's the percent grade? Now what are we going to do?
We gotta still turn it into the mathematical sentence.
A
So
sentence would be good. Can you turn it into sort of a sentence and then we'll switch it to math?
I'll go, I gotta start from the backwards. So the grade is in, right?
Yeah. Grade
We're,
is,
in,
yeah,
and then, uh-oh.
Yeah, my brain took a nap just then.
what is the total?
What is,
20.
120. The total is 120. So it's 96 out of 120, isn't it?
Mhm.
oh,
But-
90 times
Well-
120 equals in?
Actually, 96 is what percent of 120? That would do it. Now,
Yeah.
here's where the proportion way might have helped. If you didn't know the percent, which is what you were trying to find, But you did know that the total was 120, which belongs on the bottom. A lot of times the total is, that's where it belongs. This was 96.
Mm.
Maybe that appealed better for this problem. What do you say?
It's in over 100 because we're looking for the percent. That's why we can,
Right. So if we knew the percent, we would have written it right there over the number 100. But we don't. And so that's how you would do that one. That's not bad, is it? The rest of it is just struggle through. So n times 120, I'm going to call it 120n. And this is 100 times 96. So when you multiply by 100, it's just 2 more zeros.
Mhm.
I'm going to divide
It's not-
by 120. And frankly, when the numbers get like this, you can do them by hand or not. 9,600 divided by 120 turns out to be 80.
It's 8 times.
So this number right here is 80. So if a person got 96 right out of 120, their grade is 80%. Does that seem about right, that you'd get a pretty good grade for 96 out of 120?
Yeah.
Kind of have to see, does that feel right? And it does, doesn't it?
Mhm.
And that'll avoid decimal errors, obvious errors. So,
So if it says what percent, so if we're doing a problem where it says this number is what percent of that number, we
Yeah.
can always turn n into a fraction and do a proportion.
that's right, you can, if that made it easier. Now,
Okay.
the other one, I mean, this was the other direction. 96 is what percent of 120. Notice the use of the 120, which is the total after the word of. That's pretty obvious. This might be easier to follow. I don't know. I think that's why they show two methods.
Mhm.
Okay. So I think that's what I want you to do. I think the timing, the class is pretty much over. Let me stop the recording.